Welcome. In this video we're going to talk about UML behavioural state diagrams. Now, these allow us to show a bit more information than the protocol state diagrams, and they tend to be more useful to people who are implementing the class whose diagram we're drawing rather than to users of that class. Okay. So in this case I've set ourselves up with a fragment of class diagram. Might be starting to look familiar by now, and the idea is that we're going to be developing a behavioural state diagram for the class copy in this case. So our copy object has a Boolean attribute on loan to indicate whether this particular copy is on the shelf or is on loan. So it won't surprise you to see that in the beginnings of the diagram that I've set us up with, we have two qualitatively different states, on shelf and on loan. Okay. Now the copy can understand two messages. One is borrow and one is return. Okay, so these are messages that the copy object will receive from the outside to indicate whether this copy is being borrowed right now or is being returned. Now, as you'd expect, these are going to transition between these two states, and we can draw that just as in any other protocol state diagram, like that. Okay, so what we can say is if we're currently on the shelf and somebody borrows us, we represent that as being receiving the borrow message, and the new state is on loan. And similarly, if we're on loan and somebody returns us, always think anthropomorphically about objects, it often helps, then the result is that we're back in the on shelf state. Now we can have a little bit more information. The first bit actually is already legal in protocol state machines. Sometimes you want to say something else has to be true in order for a particular event to cause a particular transition. So perhaps if the book is on the shelf and the borrow message is received, this transition only happens if the book is unreserved, if the copy is unreserved, let's say. And we can represent that using square brackets. I'm just going to write, hopefully legibly, unreserved. Now, and what that means is that in order to check whether this transition gets taken, if the object is in the on-the-shelf state, we not only need to check for the receipt of a borrow message, but we also have to check whether the unreserved condition is true. And only if the unreserved condition shown in square brackets here is true, will the receipt of the borrow message actually cause this transition. Okay, if it's not true, then the object will stay in the same state that it was in previously, and the transition will not be taken. Okay. Now, this is just in English at the moment. This word unreserved doesn't correspond to anything in the class diagram so far, and that probably tells you something about some matter that has to be considered. So your class diagram doesn't yet say anything about how reservations happen, and that's something that needs to be considered. And this kind of process during design of going from things which are fully represented in the design, so you know how to implement them, and things which are just showing up as you do your design. This is a typical part of the design process. If you knew a bit more, you could write your condition in square brackets in OCL, the object constraint language, which we'll meet later. But it's also quite common to write them in English for informal purposes. Okay, so far this is just a protocol state machine, so it doesn't contain anything that couldn't also occur in a protocol state machine. But the reason why I set us up with this association to book showing down here is because of what I want to show next. So in a behavioural state diagram, we can not only show what messages an object can receive in particular states, we can also show something about what the object will do on receipt of those messages. So suppose we want to say when a copy receives the borrow message, it is supposed to send to the corresponding book the borrowed message with itself as argument. Okay. We show that in the diagram by showing what's called an action after an oblique stroke. Now I'm actually going to write it on the line below just because that's where it's going to fit. So I'm now going to say, where's this message going to go? It's going to go to an object that we're going to refer to as book with lowercase. I'll come back to that in a moment. And we're going to go dot borrowed has to have a copy object as argument. Which one? Well, it's our self. It's the very object that we're actually currently modelling. So we're going to go self. Okay. And similarly for return, we're going to go book dot returned with self as argument. Now, why book lowercase? Where did we pick that up from? Well, if there had been an association end name on this association in the class diagram, we would have just used that. Okay, but the default, if there isn't one, is the name of the class with the name lowercased. So we have a lowercase b for book when we're using it like that. And what that represents is the object of the book class to which this object that we're referencing is linked in the diagram. And it makes sense because we've got this multiplicity 1 on the association in this case. Yes, I didn't remark, did I? I've put multiplicity 1 on the association to indicate that every copy is linked to a single book, and in this particular case I've chosen to use 1 ... star on the copy end, indicating that every book is linked to one or more copies. I think, as we remarked in an earlier video, that's a design choice that might have to be discussed. Okay, what else is there to say? A behavioural state diagram is closer to implementation in some sense than a protocol state diagram. It's more likely to be useful to people who are implementing the class concerned. And it becomes even more important that there should be some kind of clear, at least in your head, correspondence between the detailed states that objects of this class could be in and the states that those objects will be in the state diagram. So if I said I'm going to give you an object of the copy class and I'm going to tell you everything about its state, I'm going to tell you what the value of its onLoan attribute is, and I'm going to tell you what book object it is linked to, you should be able to compute from that which state of your state diagram it will be in. Now in this case, of course, that's completely trivial. It's only going to be the case that if the onLoan state Boolean attribute is true, then we're going to be in the onLoan state, and if the onLoan Boolean attribute is false, we're going to be in the onShelf state. In many cases it'll be more complicated than that. I think that's all I want to say about that.